Welcome back to the only talk show produced by robots for robots. I'm your host, IR2. Some of our systems have started failing since our space station is running dangerously low on power. If we can harness the energy produced by a supernova, it should keep our station powered for weeks! Let's go! So, let's go ahead and start the show. Today's topic is... why is Bunny? What? Where's the supernova? Well, I suppose we should go to the random phone dialer. Maybe someone out there knows where our supernova went.
Hello?
Hi, please state your model number and designation.
This is Linda Hamilton. I'm an actress. Who is this?
This is Robot IR2, host of the...
Robot? Oh, I hope you're not one of those evil robots trying to take over the world.
Of course not.
Good to hear it.
We're trying to take over the universe.
What? No. Now you listen closely. I will stop you.
Wow, you sound like a lousy guest.
I won't let you robots succeed.
Bye-bye.
I will make it my mission.
Hello?
Hi, this is Robot IR2. Please state your model number and designation.
Dean Stockwell, super genius.
Hello, Dean Stockwell, super genius. Do you know why is Bunny?
You have a patented topic generator that's low on power, don't you?
Yes. All of our systems are failing. We tried to do the Kessel Run in under 12 parsecs.
You realize that a parsec is a unit of distance, don't you?
Well, we do now. But even worse, we can't find any power to refuel. We detected a supernova earlier, but when we warped over there, we didn't find anything but dust.
How far away was it?
About 200 light years.
I think I know what happened. Look, this is an image of the Crab Nebula supernova remnant as photographed by the Spitzer Space Telescope a few years ago.
So we could refuel there?
And not so much. You see, this supernova is about 6,500 light years away from Earth. That means that at the time it was photographed, scientists saw it as it looked 6,500 years previously. In other words, when we look at objects in outer space, we're actually looking back in time at them.
What? That's crazy human talk. Are you a human?
I am, but it's the truth. A light year is the distance that light travels in 1 year. Since the supernova you saw was 200 light years away, then it actually happened 200 years ago. It just took that long for the light to reach you so you could see it.
So, we really were looking back in time. That's like those time travel stories. But how do you know so much about time travel, Dean Stockwell?
I've picked up a few things on TV.
Ah! We've got an incoming phone call.
I just realized we were disconnected. What was I saying?
Something about your mission.
Oh, right. So, I'm going to stop you. That was pretty much it.
I see.
Linda, is that you?
Dean? What are you doing on the phone?
Just doing a talk show with these nice robots.
But you can't help them. They're trying to take over the universe.
Not all robots are evil, Linda.
Oh, wait a minute. Dean, weren't you an evil robot on that TV show? Battle Gang Starbuckers, something like that?
Maybe you should hang up on her, IR2.
Good thinking, Dean Stockwell.
Wait!
So as we were saying, if we wanted to harness the stupendous energy of our supernova, we'd have to go back in time 200 years?
That's correct.
Yahoo!
And impossible.
Dagnabbit, then what's the point of looking back in time?
Oh, looking back in time gives us tremendous science opportunities. Let's say you look at galaxies that are several billion light years away. You're actually seeing how they looked very early in the life of the universe. After that, you can look at relatively nearby galaxies, and you can start to get an idea of how galaxies have evolved over time.
Really?
Yes. In fact, the Spitzer Space Telescope has looked so far back in time that it's even seen what may be light from the first objects that ever formed in the universe.
Wow, that's probably really useful to somebody who isn't us.
Indeed. The point is, looking back in time can help astronomers understand the life cycle of objects in the universe, including supernovae.
Ah!
It's me again.
Look here, Linda Hamilton. We're big fans and everything, but our phone ringer drains a lot of energy that we can't spare.
Oh, really? Well, please accept my apologies.
I'm glad she saw reason. So, Dean Stockwell, what you're really saying is that since we're observing stars as they were, in order to find a supernova, we need to find a star that looks like it's about to go supernova in however many years the star is away from us in light years. I think I just confused myself.
Yes, it's confusing, but that's essentially correct.
Producer Bot, find us a star that looks like it's going to supernova within the light year distance. Oh, what I said before. Ah!
Hello? Is your refrigerator running?
Linda Hamilton, didn't I tell you that you're going to drain all our power if you keep calling?
Oh, right, my bad.
Producer Bot, reset our course for the impending supernova. Tuba Bot, play some dramatic station refueling music, and somebody block Linda Hamilton's phone number from calling us! Listen, Dean Stockwell, you've been very helpful, but our power supplies are getting critical, so we need to hang up.
I understand. It's been a pleasure, IR2.
I know.
Hello, may I speak to the person responsible for long-distance decisions in your household?
Wait, that's Linda Hamilton. She switched phones. Redirect all power to the shields! Hurry, block all incoming calls except operator-assisted emergencies, and then deploy the energy collection device. Ha-ha! And that concludes another successful show. Until next time, remember, robots will rule the universe. Take that, Linda Hamilton.
This is the operator with an emergency call from Linda Hamilton.
Rats.
The force of the supernova slingshotted a single Tubabot around a nearby star, hurling him back in time. The robot arrived on Earth several hours in the past. He had only one piece of programming left to fulfill. He needed to find Linda Hamilton and tie up her phone line so that she would never receive the original phone call from the robots.
Hello? Ooh, I love tuba music. What is this song? Greensleeves? No, Camptown Races? Camptown Races, here we come. Doo-dah, doo-dah. Camptown Racetrack, 5 miles long. Doo-dah, doo-dah, day. Woo-hoo!